try it.
This is chapter 1.
Okay. So we're confused about the oxidation reduction.
Yeah.
Okay, so for the oxidation reduction. Oh, I see. So do you know the steps? So
We can look at it.
okay,
I have this section.
okay. So for the oxidation reaction, I always have to write the half reaction. So okay, so this is oxygen, which I for this one, so to write the half reaction, so we just write the 2 plus first. Ammonia. So we can first this one. So from the stage, like we have to like balance the other like except oxygen hydrogen first. So there is no oxygen hydrogen. So we balance the atoms only zinc. So they have already balanced. So then the last state is I just write down here. So the first thing we have to balance is atom. Except oxygen and hydrogen. And the second state is balance the oxygen. The third one is hydrogen. And the fourth one is charge. So there's no oxygen, hydrogen, so we balance the charge. So this part is neutral, the charge is 0. So but this part is 2 plus, so we balance it. We have to add like 2 minus charge. Right, so we have to add 2 minus here. And so this one we finished. And for the 3 minus, so for this one, the first the atom is the oxygen, hydrogen, and the nitrogen, so it's balanced. And then we balance the oxygen. So there are 3 oxygen. We balance it by water. So we have to add H2O. But at one H2O only have 1 oxygen. There are 3, so we have to balance like 3 H2O. And then we balance the hydrogen. The hydrogen there are 4, there are 6, so it's 10 hydrogen. So 10 hydrogen we balance it by H plus. So we have to add 10 H plus. Right, that makes sense. So now we balance the charge. For this part we have have plus 9 charge and 1 plus 10 plus 9. And for this one, we have only plus 1 charge. So now we have to add 8 charge here. Have to add because the E minus is 1 negative charge. So we always want to do the plus instead of extra. So just plus 8 here. So everything is balanced. So now we just need to add the two reactions together. So like we have to you see the reaction, there is no charge, so we have to balance the charge first and then add them together to cancel. So there are 2 and there are 8. So we have to times 4, the total times 4. So this will become 8 charge, and this is 8 minus. So that is together and so the final will become it will become 4. So this will cancel. This is hydrogen. This times 4, this will become 4. 4, 3, plus NH4, plus 3H2O. So you can see this is the final balance reaction. But now you see this is in H plus. It means the reaction is in acid reduction rate. So if you want to convert it to base reaction, you have to add that. If you like, if this reaction happens, if this reaction happens in base, so it shouldn't have any H plus. It will react with base. So now just like so now just add the the acid-base reaction is acid plus base and general water. So there are 10 H plus groups, so you have to add like 10 OH minus to neutralize, right? So you just add 10. So you have to like add 10 minus here at both sides. Like both sides, so it will become and 10 OH minus plus 10 H plus, and it will be plus 10 OH minus. Right. So and then you see these things will react to generate water. So you see it's 10, 10, so it will generate 10 water, right? the chem water, the chem water will like cancel this green water review, so the final usage will become the 7 water. So this is a reaction in base condition.
Would you have to know what those
It depends on the question. If this, for example, this question, like if we finished here, we can see it's in the acid condition, but the question asked for is a basic solution, so we have to convert it to the base. So just like we convert to base, it means there is no H plus. We have to neutralize by this acid-base reaction, and neutralize, and it will generate water. The water will like the reaction. You should be careful. So here they will be cancelled each other. Okay, so try another. The date is only oh yeah. Okay. So like just 2 days. But everything else is right. I don't know how they get also.
But this is fine. This is fine. Yeah. The class I just didn't understand.
Maybe okay, so we can do this one. This is example from class. So so first thing that you write down the half reaction. So for the sodium, the chloride. Yeah, so okay. So first process we have to balance the atoms, that oxygen and hydrogen. So for this reaction is balanced. And then we have to balance the oxygen. The oxygen. So we balance it by add water. So there are 3 oxygen here. So we have to add water. One water we have one oxygen. So we should have 3 oxygen here. And to balance the oxygen, then we balance the hydrogen. So there are 6 hydrogen here. So we have to add 6 hydrogen plus. And the last thing is to balance the charge. This is the neutral charge, and there are negative 2 plus 6 is 4. So 4 plus, we have to add 4 minus 1 charge to get the neutral charge. Okay. So for this reaction, first the atom is the oxygen hydrogen, so that is, and then balance the oxygen by add water. So there are oxygen on that side. We have to add 2 oxygen here, or 1 oxygen here, so it's 1 water, and then balance and there are 2 hydrogen on the right side, so we have to add 2 hydrogen on that side. So, and then the charge, this is 2 plus 1 plus 1, so this part is negative 1. So, so it's not natural anymore. So, so the main idea is to keep both sides the same charge. So you can add two negative charge here to get the left side to the negative 1 charge, or you can minus 2 negative charge on the right side to get the positive 1 charge. So it doesn't matter. So we always do the plus. So we just plus 2 negative charge here to get the total negative 1 charge. And then you just add them together. So as you can see, this is only 2 negative 1 charge, and there are 4 negative charge. So 3 times. So this reaction 3 times 2, right? So all of this is times 2, and this will become 4 negative charge, and plus them together. So it will become 4H plus 4OCO minus plus 4E minus. Sorry. 2OCO minus and 4 charge and plus S plus 3 water. So the left side adds the right side. So and it will become 2Cl minus plus H2O, 2H2O plus 2H2O and plus SO3, 2 minus plus 6H plus 4E. So now the 4E will cancel, and 4H plus, there are 6H plus. So finally, there are only 2H plus left, and there are 3 water, there are 2 water. So finally, there are 1H water on left side. So eventually we will get 2OCl minus plus S plus water and 2Cl minus plus SO3, 2 plus 2 hydrogen here. SO3, 2 minus, oh yeah. 2 minus, yeah, and so now you can see in this reaction you have 2H plus. So this is in the acidic condition. If the problem asks you to write down the reaction, this condition is basic condition, so you have to add it. So let's add 2O. So if this is basic condition, so this just need to add this on each side. So like 2H plus, so 1H plus always compare with 1 OH minus. So there are 2, so you have 2 OH minus. And 2Cl, everything is the same, plus 2 OH minus. And if this acid-base reaction, eventually it will generate 2 waters. It will generate 2H2O. So now be careful. There is 1 H2O this side and 2 H2O on right side, so you have to cancel it again. So eventually there are only 1 H2O. Yeah. So just like add OH to become a basic condition. And yeah. Okay. So yeah. If not, I can give you did we have this equation on Thursday? Yes. Okay. So, but they didn't like this on Friday. So here is so this equation is pretty important as well this one as well. Okay, so this is about chapter 11, the gas. So another very important equation with equation of A over square root of F and B over. So those two equations are important, especially like this one, just like the proportional is, but yeah, the order is like different. So here is an example for this one. Here is a example for how to do like so under condition for which chloride gas has an equation rate of 2.4 times 10 to the 96 more secant in diffusion rates of burning gas. So for this problem, like we know the diffusion rate of the chloride, and we know the molar rate of chloride and bromine. So we can use like this equation to do it. So the chloride over, I should write down the bromine to chloride will equal the mass of chloride mass of bromine. So yeah. But this is a ratio that you have to figure out this. The inflation rate will you may use this to times
So diffusion rate diffusion rate of flow rate. What would that diffusion flow from is equal to 4 times 10 to the minus 10?
No, this is only for the rate of the chloride. No, this is the chloride has an inflation rate of the 2.4 times 10 to the negative 6. So this because we have to use like this equation. So this is we only know. It seems like we only know this part. This is 2.4 times 10 to the negative 6. This is the fusion rate of chloride, and we know the molar rate of chloride, and we know this is we have to use this equation. And so the chloride, the molar mass of chloride is times 2, and bromine is so like that. Just this equation, like we can only find the diffusion rate using this equation. Just be careful, like this is the mass of the P and the mass of P. So it seems like the atom is more heavy, the inflation of the flow is more slower. Because eventually the UDR will equal 1.6 times 10 to the negative 6. So it's like less than 2.4. So this equation. Okay, for the square root and the order for. So another point for mention is precipitation. So the precipitation of solid didn't have the ion. So for example, precipitation. You then pray and the professor will give you the form to about the classification, like which things is not dissolved water, like which things is solid. So so you have to. So for this one, the PbI2 solid. So you have to write down S here too. Yeah. So and for concentrations, the total ionic equation. So total ionic. So the aqueous can form the ionic can form ion. However, the solid, the diffusion cannot form ion, so you have to write down the I2 as here, not Pb plus 2 No, not ion. Not ion is right on the whole precipitation. And for the main ionic reaction, as you can see, only the Pb2 plus and iodide react. So the main ionic reaction only plus 2 iodide and 2. So the same, you can write down the whole compound here instead of ions. So two things do not have the ion, one is the liquid and the liquid. using for the liquid don't have. Yeah, I think our yeah, the time we are seeing. Okay, so yeah, I can go through questions because we will have them. So we'll go through how to use these solutions. So first, we have to know the units for those things. So the unit for those things, the n is more, r. So the okay, okay, good. Okay. So the temperature, so for this is Kelvin, not Celsius, and T during the temperature, and it's mm mercury or star or it's at yeah, 18. So the units are really important because the question can be really tricky. It can count, it can change the units, so you have to convert it first. Yeah. So for this question, you have to remember the standard. So what's the final ratio? Okay, so we said B mm mercury after 2 gram helium to a vessel of 10 liters fixed balloon already contains 25 Celsius degree and 740 mm. So for this one, it's not easy. Oh, sorry. Communication. So for this one, we just like there something to mention. So this is Celsius, this is mercury, and this is mercury. So so first we have to convert those two units to the standard units, which match our equation. So this one, you like I think he will give you equation like how to convert it to the standard. So it will be 25 plus 273 Kelvin, and this will be over APM. So first we have to find, we use this equation and we've got P will equals P over V. So now we know V is 10 meters and we know T. We know T. It's 25 plus 273 Kelvin. And when you R, it's a constant. But what's a K? What's a mole? Is that oxygen or K? So it's a mixture. But now we only know 2 grams of helium. We can find the mole of helium. But we can't find the oxygen, the mole of oxygen, because there is no gram. So how to find the oxygen, the mole of oxygen? So as we can see, N equals another thing about this equation is N equals P3 over RT. So in the old systems, we know the T, we know the E is 410 liters, and we know the old pressure is 7 over. So we have to use this equation again to find the mole of oxygen. So it's not easy because I have to apply this equation twice. So yeah, so that's the thing, because from the problem, like it seems like we have to add the heat, the container first have oxygen, and we say it is the oxygen. This is 25 and so from the old system we can find the mole of oxygen, and now we add the helium inside, and since the temperature won't change because the temperature depends on the outside condition, but the pressure will change. So the question is to find a new pressure. So from the old system, we can find the mole of oxygen. So eventually, it will equal 0.398. So now we can apply this. We can apply our first equation. P equals 10 and total. R T V. So the total is N oxygen plus N helium. The same R, the same P, and the same V. So plus the N of helium. The N of helium equals the mass over molar weight. It's easy to figure out. It's 2 grams over 4.003, like some number, and eventually you know this, and this, you know all of this. So you will get the final answer. And are we done? No, because this is ATM, the unit is ATM, but they have to find the mercury. So you have to convert this again. You have to do this step by step. So that is it.
Are they adding to food and final that
Because this is, this is a system that consists of the definition of this equation is the gas is the mole of gas. Or another way to think about it, yeah, you can use another way to think about it. Another changer. So now another way to think about this is a system. It has upstream and helium. Like oxygen will like occupy some pressure, and helium will occupy some pressure. Right? So the total pressure will be oxygen plus helium. Yeah. So now you will get NR. NRT over this is oxygen plus helium RT liquid. So eventually it will become helium RT liquid. So like this is like difficult problem. You have to think about it step by step. And be careful about the fluids that come out of it. Just remember the standard units for this equation. If it's called, if it's not open or this is not Kelvin, you cannot use this equation. Thank you. You're welcome.